Happy to be Friday again. Okay, welcome back to our channel, Math A and A. Okay, now we are on 1.4 binomial theorem. Very useful theorem, and the calculations are a little bit complicated, especially talking about some concept of combination. So first of all, we have a new term we need to introduce to you. We call it combination N and R. N and R are integers. We call it NCR in the new curriculum. In the old one, they will say NR bracket. Now they use more in NCR in the new curriculum. So, but don't panic. You can calculate it quickly by the calculator. Bring your calculator, you can calculate. You can choose AC3, AC4. It's just a number. Okay, so relax. Okay, so what is it by definition? Yeah, by definition, first of all, you need to learn what is a factorial. It's a concept. And factorial, it means that multiply all the integers smaller than or equal to n together. 3 factorial is 1 times 2 times 3, okay, it's 6, okay. So n factorial is also a number. Multiplication of all the integer smaller than or equal to n, okay. And then the other one is more complicated, but it's a complicated factorial and exclamation mark. Okay, we form the concept of a combination of R from N, NCR, NCR, and so you see very different way to write it. But now IBDP like this one in the mark scheme. Okay, actually you can write any like, but the mark scheme is this one, NCR. And what's the definition? Okay, is this a fraction between the n factorial over 2 factorial. One is R factorial. The other is n minus r factorial. So it's the combination of r from n, okay? We call it NCR. Later on, we will learn something called NPR, okay? Okay, and then get familiar to it so you can think about, look at the definition. You work on some special value. For example, if r is 0 or r is n, what will happen to this definition? If r is 0 first, okay? R is 0, so n factorial over 0 factorial. We have to have a new definition. 0 factorial is 1, okay? I forgot to write down here. Maybe you have to remember 0 factorial is 1, okay? Just like 1 factorial is 1. And then this one is n minus 0. Oh, n minus 0 is n. So n factorial, so cancel out. So becomes 1. Yeah. And the other is n minus 1 or n 1, okay? nc1 or ncn minus 1. You try to substitute inside. Yes, you got it. The result is n. So try to work on it a little bit. For example, you can do the substitution games. Okay, 4c 7c4. Okay, you do the substitution for 7 factorial over 4 factorial, 7 minus 4 factorial, and then you got it. How to simplify? Just remember 7 factorial, 4 factorial. What's more for 7 factorial? 7, 6, and 5. Right? 4, 3, 2, 1 is the same. So cancel out. And the numerator becomes 7 times 6 times 5, and the denominator is 3 times 1, 2 times 1. And then simplify is 35. Although, of course, in paper 2 and paper 3, the calculator can help you to get it. But if it happens in paper 1, then it's expected for you to remember this definition and work it out, okay? And then, okay, even in paper 2, they can do it in this way, okay? They give you some variables, okay? N is an integer, okay? Try to change it to a quadratic form of n, okay? If you forget the definition of NCR, go back, okay? Pause the video, bring up the paper, remember, working, and you will learn it. Don't just watch, okay? Just watch, you learn not so efficient, okay? Work on it, okay? Pause. Welcome back, okay? Remember, definition. Numerator is 2n plus 1 factorial. Denominator part is 2n minus 1 factorial, and the other is difference, okay? Large minus small, difference factorial. And you can see this term has 2 more terms. Which 2? 2n plus 1 and 2n, okay? And this one, look at it clearly, okay? 2n minus 2n, oh, cancel out, just 2 factorial. So 2 cancel out, 2n plus 1 times n, or 2n squared plus n. So neat and tidy, okay? And you did it. Yeah, can you imagine this very complicated process? You can go through it, okay? But it is required by the IB curriculum. So work hard on it. You can go to do a textbook problem or do some past paper on it, okay? And then binomial theorem, NCR is used to expand what? A plus B to the power n, okay? And we said that all the coefficient is an NCR. NCR is the coefficient, okay? And it has the standard form, okay? Okay, expand it. The first term is a to the power n, is NC0. Second term is a to the power n minus 1b, NC1, and then blah, 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 blah. The last one is a b n minus 1 is n and nc n minus 1. The last one is a b to the power n ncn. Okay. So you do the expansion, you will see it like this. Okay. Later on, we have some rules to find out these coefficients. Okay, some beautiful rules and some neat and tidy way to write it down by summation and then Pascal triangle. Okay, and you can see the term a change from a to the power n to a to the power 0, right? So how many times? N plus 1 term, n plus 1, n plus 1. So we have to remember some special case. Okay, cubic and the fourth, 1331 and 14641. Okay, it is worth to remember. Okay, don't do it with the definition every time, then you'll be too slow. Okay, and then at some problem, sometimes they are a is a fraction. Okay, so be careful about the coefficient and the constant, and they can be negative too. So be careful whether they are negative or positive. Remember, square, fourth, still positive, cubic, fifth, and then negative. So for example, expansion x minus 2 all to the power 4. Okay, remember 14641, and then multiply the terms inside. Remember minus and x, and then you see minus plus minus plus. Okay. First side is you don't know what happened. Just bring your paper, try to work it out, and you know it. For example, this example. Okay. Expand this thing in descending order of x. Okay, so x6, x5, and x4. So 3 terms only to x4th term. Okay, remember the definition. Try to work on it. Very complicated. The coefficient is scary to you, but you can do it. Okay, after you tackle it, you find it easier. Pause and work. Okay, welcome back. Okay, yeah, x6 and then 6 x cubed. And then 6 times 5 over 2, 6 fourth minus 1 over 3rd square, and then all the other term is lower. So they get, okay. So x fourth, and then do some simplification. Remember, it's a math. Okay, keep it as a fraction. Okay, with one exact value. Not in the science. Science you need to make it a decimal number. Right? We want exact. Okay. Got it? Yes, complicated. So maybe it is some time for you to work on the exercise. Okay. Maybe you can pause here, come back later when you get familiarized more. Okay. Okay, Pascal triangle is a good way to remember the numbers. Okay. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Remember 1, 4, 6, 4, 1, and 1, 5, 10, 10, 5, 1. Okay. Remember the pattern? Okay, see the pattern of the coefficient of the terms. Okay. Yes, each coefficient is the previous two coefficient neighboring summation. Yeah, so it's the good way to remember it. Okay. But actually, you can remember this n to 0 to 4 is excellent. Okay. Use the Pascal triangle to expand it to cube. Remember it's cube? 1331. Okay. Okay, try to do it. Remember, don't make any careless mistake. You can do it. Okay. Pause the video. Welcome back. Okay, it's checking time. Okay. Yes, very complicated each term. Although you remember 1331, simply easier already. But each term x and y are complicated, and then after the expansion, you got this. Got it? Well done. Okay, next one, the summation notation. We want to find out that the binomial expansion is too complicated. Right? They're like this. Okay, so we want to have a summation notation to help it. Okay, it's the first time for us to learn it, so we learn it slowly. Summation. This is a summation sign, and then we have the a n. N will change. Okay, it means the parts. Okay. A n will change. Okay, n start from what? Start from the bottom. I say start from n equals h. Okay, n to k, and then each time is a 1 increment. So n plus 1, n plus 2, n. So start from h to the first term ah, and then increase by 1. So ah plus 1, and ah plus 2 plus 3 plus 4, and last one is k minus 1, and then ak. Okay. So it's the summation notation, very clean and tidy. For this long expression, make it one term. Okay, look like one term. So for this expansion, you can see the pattern too. So n m. Okay, m is 0. So start from 0 and then n as n. Okay, so we take this NCR, the bottom one as the bottom number as m. Okay, it would start from 0 to n. So m equals 0 to n and m. Okay, so how to express it? General time, you see each time. Okay, when m increase, the coefficient, the exponent of a decrease by what? By the number of m. Right? So a n minus m, and the exponent of b increases as m. Okay, bm. Okay, so this is the equation. We use this one more. Okay? So remember this one. Okay, it is the real least entity definition of binomial expansion. Okay, the summation m equals 0 to n, NCM a to the power n minus m b power m. Okay, remember it. Okay, very important. Okay. Okay, in summation notation, just again, we try to express it in the summation notation, just by definition, and then let's look at the expression to see anything you can simplify it as clean and as tidy as possible. Pause and work on it. Welcome back. Okay. Definition. My m equals 0 to 4, okay? And then NCM, okay, x to the power. Oh, sorry, this should be x to the power m. Okay, sorry, this is 4. It should be m. Sorry, it's about m. Again, it's about. Oh, so some problem here. Okay, it should be m. Okay, it should be 4m. M minus v. 4 minus. Oh, so I make a mistake. It should be m. Sorry, it should be m. So m minus v. 4 minus m. Okay. Oh, so I make a mistake. So the final result should be. Oh, sorry. This one should be m. Okay. Sorry. It's m. Okay. So it should be negative. So it should be 4m minus 12. Sorry, I make a mistake here. It should be m. I apologize. It should be 4m minus 12. Okay. Yeah, you're right. You got it. It should be 4m minus 12. I careless mistake here. It should be m. Sorry. So the coefficient of terms. Okay. So you need to remember the coefficient is like this. Okay. And sometimes we will take trick with the coefficient, and even the a and b can be complicated. X to the power p, x to the power q. Oh no! And then add them together, and they will be very complicated. X to the power of this, but no need to remember it. Just in the real situation, they give you the number, and then you will encounter this way, and then you solve it. Okay, and then finding out the real x to the power of our term. Okay, and then you can find out the constant term, coefficient of different xr term. Okay, got confused? Yes. So we work on it. You understand. Find the coefficient of y to the power 6 term. Okay, how to do it? Yes, you got it. Okay, I want y to the power 6 term. It means that this term has to be cubic, right? Cubic term. Then this is the fifth, right? Fifth. And the coefficient is AC5 or AC3. They are the same actually. Okay. So general solution. And then you notice it. Okay, I got it. M equals 3. Okay. And then the AC3 cube and then fifth. Okay. And then all this thing add together is negative 108,864. Wow, big number. How can you imagine you got it? Okay, without this summation sign helping and then looking this knowledge. Okay, you are improving. Okay, just need to do more exercise. Okay, and then products of polynomial. Wow, even crazy when you got the one polynomial is a trouble already. Right, two polynomials multiplied together. So you need to simplify each polynomial first. Okay, don't do it too much. Okay. Simplify them, make them neat and tidy, each of them, okay, and then do the multiplication then. For example, you substitute this thing inside. And then they find out the y squared term disappear. So when you substitute this inside, so the first three terms have the y squared term, right? And they said that this y squared term exactly cancel out. So the coefficient add together is 0. So what's the value of h? Try to work on it. Pause and work. Welcome back. Okay, look at them, just substitute inside first. Then for the first term, okay, for the y squared term, okay, so it's a 6x squared. For this one, okay, this one is a 3h, okay, negative 18. For this one, y squared term is just 12, okay. And they ask that this is 0 because the y squared term disappears, so the coefficient is 0. So simplify it, quadratic equation. So it's 2 or 1. Good question, good written, pass paper. So thank you for going through with me. Okay, it's a very important subject, binomial theorem. You learn new terms, okay, factorial, NCR, and the summation way to express a long expression. It is very hard. Okay? But what you need to do is just calm down. We watch the video again, and then work on the textbook problem or get some paper to work on it, and I'm sure you can learn it. Okay. If you like our sharing, remember, share with your friends and subscribe and then like our video. Okay. See you next Friday. Math ANA. Bye.